balancing equations, and conservation of matter. Sometimes it's called conservation of mass. It's the same thing. The law of conservation of matter in a closed system matter cannot be created nor destroyed. Key part that you might not have heard before, it has to be a closed system. A closed system would be like if everything is a solution, if you're producing a gas, that has to be in a sealed container of some sort. Spilling, that type of stuff is considered not the closed system too. The law of conservation of matter is the basis of many labs. If your total mass of reactants is 14 grams before, afterwards the total mass of the products should be 14 grams afterwards. So the mass before equals the mass after. When we come to balancing equations, this is the same deal, except it's on the atomic scale instead of the gram scale. So the atoms are conserved. Atoms cannot be created nor destroyed, since all matter is made out of atoms. The steps of balancing equation is, if you need to, you write the formulas. If they give you a word equation, you got to write the formulas. You got to write the formulas down correctly. Do not change the subscripts, the bottom numbers, to balance. If it's writing the formula correctly, go ahead and do that. If you write down water as HO by accident, then you go back and check and say, oh, that's supposed to be H2O, that's okay. But if you need 2 hydrogens and 2 oxygens, you cannot put the 2 after the O. If you need 2 oxygens, the only place you can put it, if the formula is written correctly, is in front. You can add coefficients. When you do the coefficients, you are multiplying the atoms. So here you have 2 times 2 is 4 hydrogens, 2 times 1 oxygen. So if you have your basic formula, hydrogen plus oxygen yields water. Water is written correctly. Hydrogen and oxygen are diatomic. You got to remember those. The hydrogens are correct. The oxygens, you need 2, but you only have 1, so you multiply by 2. Well, now you got 2 times 2 is 4 hydrogens, so you need to put a 2 there. And then make sure you go back and check. 2 times 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. 2 oxygens. Distribute the 2 oxygens. So that does work out. If you have a odd number of substances, let's say we have ClO3 decomposes to form NaCl plus O2. The oxygens occur here in an odd number. The oxygens occur here in an even number. You have to get an even number. So if you have an odd and an even, you got to do the odd number by 2 to make it an even number, and then go on from there. So if you have that situation, do that. So 2 times 3 is 6 oxygens. So multiply by 3. 3 times 2 is 6 oxygens. 2 NAs, 2 NAs, 2 CLs, 2 CLs. This is called by inspection. Maybe in middle school or in biology, you did the accounting system where you list all the atoms and wrote down how many you had. And then you try to balance them that way. It's the same thing we did, except here you're writing them out more. It takes up more space. It's okay to do it that way, but so you need 2 and 3 is the least common multiple of 6. So you need to multiply this by 2, which makes that 6. But now it's 2 and 2. Here you need to multiply by 3. You put a 3 in. 3 times 2 is now 6. 2 CLs and 1 CL, so you need to multiply both these by 2. Now you got 2 and 2. The inspection and this accounting method work exactly the same way. This requires a bunch of space. The accounting system is this much additional space. If you go back and do the inspection system, it works the same way. I prefer the inspection system pretty much the way that I do things. If you have a situation where you have an element by itself, let's say FeO. If you have an element by itself, do that one last. Balance everything else except for that. Then that way you can make sure that you have the correct number of things. If you put a 2, 3, 4, 17 here, it's not going to affect any of the oxygens that you also have or irons. So you have 2 here for iron, so you put a 2 there. And now you have an odd number of irons. No, you got an even. So you got 1 oxygen here plus 2 oxygens. So the oxygens are good. 2 irons and 2 irons. The irons are good. So you need 2 more additional sodium. So I would just throw the 2 in there and you're done. Throwing the 2 on the metal by itself or the non-metal by itself is the best way to go about it. Another common type of reaction is a combustion reaction. C2H6 plus O2, CO2 plus H2O. You need 2 C's. The order you do these combustion reactions, you do it in order here. You do the carbons first, then the hydrogens, then the oxygens. So you have 2 C's, so you need to put a 2 there. The H's, that's 6, so you need to put a 3 there because 2 times 3 is 6. Now when you do the oxygens, you have 2 times 2 is 4 plus 3, that is 7. So how can you make it that'll work? Well, what you do is you put in 7 and you double everything else up. So 7 and 2 is 14. So you gotta put 7 there. But this has to be double, so you gotta make that 4 and 6. And now you have that, so you gotta double that. So if you need an odd number of something that occurs in pairs, what you do is you put that odd number in and you double everybody else. So that's the lesson on balancing equations. The best way to do is practice, practice, practice.